So let's now continue our discussion. So can you guys see my screen now?
Yes, sir.
Okay, so before we start, I just would like to check whether you guys are really there or no. So just type present, okay, and then put it in our chat box so that I can see that all of you are here already. So just say present, present, present. Okay, it's good. All right, it's good. Okay, so it seems that most of you are here. So here's now the corrected, okay, PowerPoint or slideshow. So in example number 2, I've already put 75 milliamps here. So before this was just 75, but right now it's now milliamps or 75 milliamps. Then the another correction here is this one. So before this one is example number 2, but right now, I've just changed it into example number 3. So the same with this one solution number 3. And then also with this one, IL. So before this one is IL minus, and then right now this one is IL equals. So later on, I will upload the updated slideshow. Okay, so just download the updated one. So do not download the outdated one. Okay. So we've just finished solution number 3. So do you guys have a question or clarification so far regarding with example number 3 before we proceed to the next example? None yet, sir. All right. So how about the others? You guys have a question or clarification? So none coming from Mr. Pumano, Mr. Eda, and then coming from Mr. Charles. None, sir. All right. That's a good thing. Okay then, so it seems that there is no question for now. Okay, so as soon as you've encountered a problem or a clarification, so don't be shy to ask me anytime. So feel free to ask me, or you can message me directly to my messenger. Okay, if you have a problem. So next one is example number 4. So before we have RL as a missing variable and then RS as a missing variable. And right now, oops, yeah, VS as missing variable before. And then right now we have RS as a missing variable. So we have to find the minimum resistance wherein this Zener diode will still work. And then the maximum resistance wherein this Zener diode will still work as a Zener diode. Okay, so find the minimum and maximum value of RS. So without a further delay, let me show to you the solution. So in this scenario, okay, so as I have mentioned a while ago, always solve for RS minimum, right? Or the minimum requirements. But in here, uh, we have to solve for the RS max first, okay, or the maximum value that is missing in terms of RS, okay? Because you know, once you find the maximum voltage here, it's easier to find the minimum requirements here because all you need to do is get the Vs minus Vc divided by Vc. So you will be able to get the Rs max at that moment. So once you're done with this, you can now move on with the Rs mean, IL, and then Is max. Actually, you can solve or you can solve first either of those two. But of course, you have to solve for the easiest one first. So in this case, the easier one to solve is the RS max. Okay, so we will solve for the RS max first. So the formula for the RS max is equal to RL times Vs minus Vz divided by Vz. So RL is already given, Vs is already given, Vz is already given. So all you need to do is substitute those corresponding or their corresponding values. So RL is 5K, is 1 divided by 12 minus 4 divided by 4. So just do the math, then you will be able to get 10 kilo ohms. Okay, so this is the maximum resistance that we can have in this circuit if we have those corresponding values. All right. So next one is solving for the RS main, but Then again, before we can solve for the RS min, we have to find the IL and then the IS max first. So solving for the IL first, so IL is equal to VZ divided by RL. So VZ is 4 and then RL is 5K. So just do the math, then you will get 0.0008 ampere. Okay. And then once you have the value of IL, then that's the time that you can solve for the IS max, okay? Because the formula for the IS max is IZM plus IL. So IZM is already given in the circuit, which is 45 milliamps, and then IL is already solved, which is 0.0008. So just substitute their corresponding values. So 45 milliamps plus 0.0008 is equal to 0.0458 amps. Okay, or this one is 45.8 milliamps. 1, 2, 3, yeah, 45.8 milliamps. All right. And then once you have the IS max and then the IL, then that's the time that you can solve for the RS min. Okay, so we have this formula coming from IS max, wherein IS max is already given, VS is already here, VZ is already here, and then RS min is the only variable that is missing. So if we have one missing variable or one missing value in an equation, then we can just simplify that one, and then we'll be able to solve the missing uh, variable. So from here, IS max is 0.0458, and then Vs is 12, and then Vz is 4 divided by Rs min. So just simplify this one further, you will have, or you will get this equation. So 12 minus 4 divided by 0.0458. So just solve for this one. So 8 divided by 0.0458 is equal to 174.67 ohms. All right, so that's how you solve for the RS min. So the maximum resistance that is allowed on this Zener diode is 10 kilo ohms, and then the minimum that will still make this Zener diode work as a Zener diode is 174.67 ohms. Okay, so yeah, do you guys have a question so far regarding with this one? Well, actually, the one that you're only checking or verifying is the answer and then the corresponding values if it's correct. Because for now, of course, you don't need. I mean, you don't know where this formula came from, where this formula came from. Well, if you're going to check some articles in, let's say, in Google, it will show to you, okay, the complete formulas for the RS max, RS min, IL max, IL min, and many more. Okay, so the explanation and how did they arrive on that formula is also in there. Okay, so I want you guys to explore the basis on how did they arrive on those formulas, because in my case I just showed to you guys on how to use or on how to apply those formulas. Okay, so your main job here now is to know why. Okay, because it is now your own understanding why we have to consider this resistance only to solve for the IS max, why we have to consider this one only on getting the IL min or IL max. Okay, so actually with the use of Ohm's law, you will be able to understand why we have that formula and then why we have this and that. Okay, so familiarizing that one is quite a challenge, but it's a good thing that you're challenging yourself. Well, if ever that you're not challenging yourself, so it's also a good thing because it's already there. It's an online distance learning, so it's up and load, so no problem. So you don't need to memorize, but it's better if you will be able to memorize it, because you will be able to solve things faster if you have already memorized the formulas. Okay, so before we proceed to your quiz. Do you guys have a question so far? Okay, so none, 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 none. All right, then that's a good thing. So in the past examples, we've just solved for the RS as a variable, RL as a variable, and then VS as a variable. Okay, so actually, as long as everything is given, and then if there is one missing variable, then we can solve for that missing variable. Okay, so no problem with that as long as we have those formulas. All right, so if you guys don't have a question anymore, so here's your quiz regarding with this module. So number one, so find the V out, current across load resistance, current across series resistance, current across Zener diode, and then the power dissipated across Zener diode. So as you can see, everything is given. So everything that is missing in here is solvable. So the current here, the current here, the current here, and then the power dissipated here. And then the V out, if ever this one is working under the Zener voltage breakdown or the voltage Zener breakdown. Is it correct? Zener voltage breakdown. Anyway, yeah, that's it. The avalanche breakdown. Okay, so this is the number one. And then number two is find the minimum and maximum value of Vs. So this is super similar with the past example, just different values. All right, so I only gave two questions. Okay, so it's kind of quick to answer. Like in just 30 minutes, you will be able to answer number one and number two, since we already have your basis on the past examples. So do you guys have a clarification with your quiz number one and quiz number two so far? So none coming from Mr. Eda. Okay. And coming from Miss Dario. Alright, so again, if you guys have a question soon, so feel free to ask me anytime. Okay. And if you want to, to have more examples, you can visit this website. So this is one of the friendliest website that I have ever seen. So it's like, uh, easy to understand. And then they are showing the step-by-step solution. So feel free to visit this one anytime. Well, actually, there's a lot more websites that you can look for the examples of Zener diode. You can even go to the YouTube, which is much more easier because you don't need to read uh, any everything. So just listen on the voice of the tutor. So here's my reference. So mostly so some of the ideas came from this YouTube, okay? And then some of the definitions came from this website. Okay, so yeah, those are my references. And then that's it for this module. So again, do you guys have a question or clarification? And if none, okay, so you may now leave and then have a blessed Wednesday to you. Okay, goodbye. Goodbye.
Bye, sir. Thank you.
Goodbye. All right. Goodbye. Goodbye.